So I'm assuming that everybody is okay. If not, just let me know. So for this session, we are going to work on the if and else statements and on the for loops. So the idea is for you guys to be able to run this type of statements or analysis with your data at the end of this workshop. So hopefully it will work. It can get like quite complicated depending on your data and how many conditions you have. But I mean, you have to start by little bits and then keep making it more complex and more complex as you go. So first, for the if statements, the general shape that they have to have, or grammar, is that you have the if, then a condition that is true, and then you say, if the condition is true, perform this action. And for the if else statements, the only difference is that you have the if in your code, then the condition, if the condition is true, perform the action. But if it is not true, then you have this else condition and you perform this alternative action. So for the example here is quite simple. And if we go, we are assigning 8 to a variable x. So if you run this, so if you run this, you know that x will be 8, right? So in this example, we have if x is bigger or equal to, is greater or equal to 10, then print the following sentence. So if you run this, you will see that nothing is print, right? Because we know that x is not greater or equal, like 8 is not greater or equal to 10. So, and you of course can prove that just by running x, you see that x is 8. So that's why you don't get anything. So in this case, it's quite simple to understand why we don't get any answer, but if your statements get more complicated, it's always better to know, okay, did my condition worked or it didn't work at all? So in this case, that's where the else come handy. And we have exactly the same condition, but then we say, if this condition is not met, then print x is less than 10. And basically this is useful because you will be able to kind of get a response from your code and from the condition that you are putting. So we can also kind of nest multiple conditions. And in this case, for example, we have the same condition as the beginning. If x is greater or equal to 10, print this. Oh, wait, sorry. I jumped. Print this. But then if it is not, if this is not met, then we are telling it, okay, now if x is greater than 5, print me this other statement, that x is greater than 5, but less than 10. And again, if this condition is not met, then print me x is less than 5. So what R is going to do is that it's going to take x, is going to test this condition. If this condition is true, it will print this. If not, it will go to this next if, and it will check if it is greater than 5. And if it's not, it will print us the last statement. So everybody gets that. If you don't get it, let me know. So, of course, if we run this, we can see we can see that we get the answer that x is greater than 5 but less than 10, which is logical because we have x equal 8. So to really kind of wrap your head around, and maybe what I have done when I was learning this type of statements is to just play around with x and change it to different numbers and make sure that the logic is understood. Before I move any further, it is also important for you to consider the, I don't know if it is called grammar, like how the statements have to be coded. So you first have the if, and then in normal brackets, you have your statement, the condition that you want to test if it is true or false, and then the result that you want to have in curly brackets. If you have an else afterwards, the else just goes straight after it, and that this can trick people sometimes. So when you are writing your code, and most of the issues or the errors that come when you are doing if and else statements, they come that you forget your brackets, or there are multiple brackets that is difficult to follow. So that's why, I mean, right now R is also like it gives you a space between things. So even if it looks like a bit long, your if statements, try to keep them open, like as separate as possible, so you can really check. Then a really important fact about the if statements is that they are looking for a logical element. So whatever you put, whatever you're testing here, it has to be true or false. If it is not true or false, you will not be able, maybe your if will run, as we will see, but you will not be able to get an accurate answer of what you are looking for. So that is also very important to take into account. So to illustrate that about the true and false, we have here, in this case now x, we are making it a vector, and we are telling it to R, tell me if 4 is equal to 3. So obviously we know that that's not true, but if we want to prove that with a if and else statement, we can do it. So in this case, we first have to tell R that we are changing our x to this statement, to 4 equal to equal 3. Then we want to see if this is true, if in case like it's hypothetical, right? And so we will say, okay, if x is true or false, right? Then print 4 equals 3. If x is not true or not true, then, or if x is false, then print me that 4 does not equal 3, as we know. So if you guys want to run this, maybe I should have shared my code so you can only copy. But I think it's useful to type here this type of stuff, because then you get used to put the curly brackets, the normal brackets, and to be able to actually understand how the grammar works. But do you think it will be useful if I share my code? You guys want me to share the? No? Yes. I can maybe go slower so you can copy the things. Everything. Oh, cool. Everything is also in the software carpentry. So if you don't want to type, you can also copy paste. So if we run this, we will see that it tells us that 4 does not equal 3. And if we only run, if we only run X, you will know that, well, R knows that this is false. So it's almost like proving that our if and else function is kind of working. So sometimes what people do when these things get more complex is that they use a known condition that is true or false to see if it is running logically and if it is actually working. So it's a way to kind of test that all your conditions are accurate. So for the first challenge, what they ask is to use the if statement to print a suitable message reporting whether there are any records from 2002 in the gapminder dataset, and then try the same for the 2012. So for this first, I think that we need to know how the gapminder data is. So if you type head gapminder, we can have a little look of the data that we have. So we have the countries, and here we have the year. That is the information that we need to use to do this if and else statement. So the how do you say, the first intuition is just to tell the if statement, okay, if in my gapminder inside of this column that is year, do I have anything that is equal to 2002, right? And then if this is true, then print me yes. So if we run this, we get this, it's a warning, it's not an error, like our if statement is running, but it's telling us that the condition has a length of greater than 1, and only the first element will be used, which means that when we are telling this to R, it's only checking if the first line of our gapminder is equal to 2002. So, and this is because if you remember what I said before, this is not a condition that is true or false. Does that make sense? So R, like, it just checks the first line because it's the only thing that it can check if it is true or false. If our first year is 2002, then it will show us yes, but in this case is 1952, so it will not show any result because it is not yes. So does that make sense? Do you understand that part? I think that's very important to wrap your head around, because whatever you put in between these two brackets is like essential for your analysis or for your data exploration to be true. So because of that, we kind of need, so this is, it just explains that if the function, if function will still run, but will only evaluate the condition of the first element of the vector. So in this case, as I said, the first line of your year column. Therefore, we need to find a condition, sorry, let me go back. We need to find a condition here that make this a condition that is true or false. So for this, the tips that we have, that is the most, let's say, a straightforward way to get around this, is to use this other function that is any and all. So the function any will return true only if there is if there is one or more values that your condition is testing. And then you can also use this function any using the operator in that I will show later. And then the function all, as it says, it will return true only if all your values in your vector are true. So do you want to have a go trying to use this function any in your if statement to see if you can find if there is any year that match the 2002. In the data carpentry, there is they go through another way, that is to first try to extract the all the years and try to see if there is any year that matches 2002. And then when they already have that as a vector, they do the if statement. That's another way around, but at the end of the day, you are already getting your answer before you run your if statement. So maybe I think that it will be more useful to start trying with the any, with the any function. That's the other hint. So I will give you maybe 5 minutes to try it. If you think that is too difficult, let me know and I can go through the solution. But maybe let's wait a little bit. Sorry, the challenge is to get a message reporting whether there is any records from 2002 in the gapminder dataset. So, and then try it with a that's the challenge one. So I don't know, for people that don't remember, to get the data from one of the columns, you use this $sign. So that's one of the things that you might need to know already. Yeah, so with as Kevin said, yeah, there is the possibility to use also in with the any function. So remember that maybe I can leave this here, that how you have to code is like if, then the condition, the bracket, the curly brackets, whatever you want to print, and then the else. Okay, so I will keep going with the solution if everybody's okay with it. So let me scroll on to the any. This is all this part is the first solution that they give in the data carpentry because, but I think it's a bit convoluted. So I will first go to the any. So here we use the any function to make our statement that we had before a true or false condition. So we write if there is any like 2002 year in our gapminder, then print that we have found records for 2002. So for you guys to understand what any does, it will literally look if there is anything, like any is the function that will look if there is any year equal of 2002 in our gapminder dataset. So any is already a function that is built up by R, so it does a bit more stuff in the background that allow us to get this answer that is true. So if we now change here for 2012, we see that we don't have any results, which means that there is no 2012 records. So again, when you're doing things that are slightly more complicated, if you get like just blank, it's like, oh, did it work or did it not? So that's why it's better to have an else statement. So just quickly to go through what they put also as a solution is to first use a vector describing the element that is equal to 2002. To do that, they extracted any year that is equal to 2002 with this this coding. So here it gives the data set, and then it says in this column from this data set in the column year, find me anything that is equal to 2002. And then the comma is just to say that is the column, right? If I'm wrong, the other people can let me know. So if we run this and we check the head of, we can see that this element that we are creating here is taking all the countries that we have data for 2002. And then after we do that, we count the numbers of rows of that data frame, that we just created, to see how many of these elements we have. And we do that because, like I created this this data frame, but you can run this without actually giving it a name. But it's always handy to give it a name to check what is your code doing. So this is the part that I guess that is slightly convoluted, because we already know here that we have 142 elements. So we know that we have some years with some countries with data from 2002. Then in the row number, we want to know if this row number is bigger or not than 1, of course, or equal to 1. And we know that this element is true. And then we wrap everything together to make it a if statement. So here we get the number of rows from this data. In this data, give me check this column year and tell me if there is any year equal to 2002. And then if this element n row, so if the number of rows it's equal, higher or equal to 1, then tell me that we have a record from 2002. So this is how, and again, you see that it works. Like we made this statement a true or false statement for it to give us the correct answer. So the handy part with any is that all of this is kind of in the background. I don't know if it doesn't do it exactly this way though. I think it just looks for it maybe with a loop, but I'm not quite sure how is written behind. So then there is this the if else, the function that is built in R as well, that how it works is that we have if else, and then you open the brackets, you put the condition. If the condition is true, then perform this action. If not, perform the alternative action. So it's like a fusion between the if and else function. So yeah, well, again, if the first argument is that if the condition or set of conditions are met, then the second argument is the statement that will evaluate if the condition is true. And then the third statement that is evaluated when the condition is false. So as an example of this, if we put y, it's a -3. And then here we write so as you can see, the coding is slightly different. Yeah, so we need a print to, I think it's to explain that that's how it comes from, and that the print function exists as well. Sometimes it's also handy to have it to visually see that your code is working, like it's clean. And then if you don't need it, you can eliminate it. But it's you will see maybe in the end, the last challenge, like the if and else statements can get super long and super convoluted. So the print kind of works to make it look like, to make sure that what you're doing and how your code is working. But yeah, you can put it without print. And also, like, if I'm not wrong, maybe someone that knows more about Bash or this is also used in when you are working with shell and like in Bash. Maybe you, Legana, know. And so if you don't put print, I don't think if it works. So I think it's it allows to kind of have a more how do you say, homogeneous coding if you put print in R and in shell. Yeah, Legana is answering there. Well, I hope we answer your question, Kath. Yeah. Okay, so here you can see that the if else statement work, that y is a negative number. And I mean, we knew that, but it's good to know. Yeah, it will, yes, it will print without. I have this personal attention, okay. Well, they are asking, they reply in the chat. So this is it for the if and else statement. So the if and else function, I don't like it very much because I find it tricky to code it when you have like multiple conditions. So I guess it depends how clear in your head it is. Okay, so now let's go a bit quicker because we only have 15 minutes. If anybody has any questions apart from the printing thing, if you get the if and else statements before we go to the loop and the for statements. No, yes. I see a yes in Karen, but you are very little in my screen, so we continue. Yeah, okay, cool. So for repeated operations, so it says that if you want to iterate over a set of values when the order of iteration is important and to perform operation on each, then you use a for loop. This is a very flexible operation for looping things. And so it sometimes is quite hard to use it correctly. I have heard this many times that to use for loops only if it is extremely necessary, and if you basically if you really know what you're doing, because it can get very computationally heavy, and then you will get stuck in your loop forever. And and so I don't know if you remember, I think that Ira was going to go through he went to the perp package that is an alternative way to use for loops when you have to do these very intensive loops and iterations. Then sometimes I think that many of us use them. I have used loops in Bash, like in Shell, but I haven't used them in R. And I think one of the reasons is because it can get very computationally hard to make an R code with for loops run. So the basic structure for it is for the iteration in a set of values that you will assign, and then curly brackets and do the thing that you want to do. So in this very simple example, we want for any I in this sequence from 1 to 10, then print me all the I's. So if we run it, we can see that what it does is it only print it. The condition here, it will any I, so it will go from 1 to 10 and it will print it. So the first is 1 and then it will print to 10. So you can also iterate any other vector, like this is a sequence, but any other vector can be iterated, and then you can also use for loops nested as we did with the if and else conditions. But again, this is when things can get tricky, and in the nested loops, we have to be very careful not to get, not to get stuck in the loop. So in this case, for example, we are telling to find any I in the 1 to 5 sequence, and then for any I in this sequence, we want to assign it any J in these other, in this vector of letters. And so these are the two loops nested, but then we want to do something with these loops. And in this case, we want to print them based in the element of I and the elements of J that we just looped. I don't know if that's a word. So if we run this, we can see here. So it picks the first element of I, then it goes to J and it prints it. And then it goes for the next element of J, and then it prints it. So we have, like it goes through the data on a loop, as the name says. Is there any questions here? It's a bit difficult to like understand it in the first go. So, no? No questions, okay. So, like here, we notice that it will go to all the elements from I, and then iterate those matching the elements of J as a, like it will go first from, maybe it's easier to explain here. Like it will go first from 1 to A, B, C, D, and E. So the first element of E, and then it will go to all the elements of J, and then it will take the second element of E, and then it will go through all the elements in J. And so this process will continue until we finish the sequence. So that's when it gets tricky, when your data is longer and when you don't put a clear end of your loop, that you can get, how do you say, stuck in your loop. So what they explain is that sometimes it's also easier to, instead of just running and having this long list, we can get a output vector. So, and then with this vector, we can work to make matrices, we can work to make other elements. So for that, we can make like a empty vector here, and then in our function in our looping, we will make this temp output, that is the temporary output, where we will paste our elements from the loop, and then the next kind of task that R needs to do is to build this output vector with the temp output when it has already, the loop has already finished. So if we run this, you will see here that we are not printing anything as like in the other code, but we are saving all our information in this element that is called output vector. So if we run this, then we get exactly the same, but save in an element that now we can manipulate. So yeah, again, they talk a lot about to be careful about these loops and how to make them as efficient as possible, because otherwise you can be waiting for hours for your loop to finish. And so one of the ways to do it is to do this, to save it in this element as an output vector. And the tip here is that it is, if you are making a loop, you kind of already know what your data is going to look like, slightly at least. So it might be easier for your, and more computationally efficient, to build this output vector in a way that that is predicted. So for example, here they give the, in our I and J example, we know that it will be a matrix of 5 rows and 5 columns, right? So when you are building your loop, I think that you should already know what is your output going to be. If you don't know, then that's one of the tricky things that you kind of need to know, try to define, because that's when the error of staying in an eternal loop comes from as well. And having this output, it also allows you to build your loop in to get what you want, mainly. So I'm a bit late. So for example, here we have, we build a matrix with 5 rows and 5 columns. This matrix is empty. And then we give like how do you call, we make the J vector an element. What did I do? Also to save it and to be able to then, in our for loop, tell R how do we want our output to be. You can do also this with the I vector. Like you can have your J vector and your I vector as elements, but here they just use this example. So in this case, what we have is that we save the values of J in this temporary element. Then we have a temporary output where we will have our I element, and then our whatever value that our loop is giving to is storing in this temp_j value, and our output will be a matrix of I and J's, built with the elements and with the information of this temp output. Does that make sense? I hope. So maybe if we run it, you will be able to see it. So here I call my vector sorry. So this will be, sorry, but I wanted to do this first. So our matrix will be built like this. Like we already say that we wanted like 5 columns and 5 rows, so we get all our information here. And to make it a vector, as we like to retransform it as a vector, we use this function as dot vector, and then we put our matrix. So from what I understand, and maybe Kevin or Jacob can correct me, we put it as a matrix because it's a more efficient way to store data. And or Legana, maybe you work a lot with this. it's a more efficient way to store data, and we can also wrangle with it once we have this information. So then there is also this function that is called while loops. And so you will need to repeat a loop until certain condition is met. So the grammar for this is while, then the condition is true, and do whatever you want to do. So in this example, we have, Legana says that she converted with data to data frames. But when you are storing the information of a loop, you put it directly to a data frame. Okay. Then there you go. You can use data frames as well. So in the while loop, what we have here is, so in this code, there are a lot of new things maybe. So the run if is just a function that generates random numbers. And then the cat function is a function that will write text, that will allow you to write whatever text you want. So here is telling, write me the information that you find from Z. And so what this function will do is that it will run while Z is greater than 0.5. So here, if we our Z we assign it as 1, then we see that it will run just, it will, in this case, it just run 2 elements. It looked for it twice because the run if show 0.07 that is lower than 0.5. And so it stopped. And so we can run it again to see, and then, so run if is a random generator number. So it will change every time that you run it. Let me think what is more. We're almost on time. So like in the challenges, there is not much else to do, only this thing that Kevin was mentioning, that is another way to use, to compare matrices or vectors. Just let me see if there is anything that you cannot do. Maybe let me know if you have any questions now while I check what is imperative for me to say in the last minute. So yeah, here you can see how big the if else statement can get. But I mean, I will recommend, I'm sorry, we are running out of time, but I will recommend for you to go through the challenges without seeing the solution, and try to actually build to perform the challenge and build the if else statements, because it will help to wrap your head around what is needed and how to write the functions. Yeah, no worries. See you, Camila. So if anybody has any issues with the challenges or doesn't understand how any code is working, let me know and I can go through with you. I think that I remember that there was a rep. So the cat function is something that I think that we haven't seen, that I already mentioned, is to print text or to write text. Then this rm is another function to remove elements from. Sometimes you need to save these temporary elements to write the rest of your loops or of your if statements, but then at the end you don't need it to. So sometimes they are really big and you need to remove them. And then the other function that where is grep? I saw grep as well. The other function that we might not be familiar with is grep. Yeah, here grep. So grep, it's another function that helps you to find a specific elements in a data set. So in this case, we are getting all the countries that start with the letter B. So grep, it works with it's built up in R, but it's already like a package, and there are many other rep package tools. It's very powerful, and it uses general regular expressions to extract information from your data. This might be a bit advanced already, but maybe keep it in the back of your mind from when you need to extract information from your data. grep is really, really, really powerful. And sometimes, yeah, you need, I think that most of the time, you need, I don't know, Legana, you know maybe how to use this better, but you need regular expressions, and that can be a bit tricky. But it's a tool that is super useful to edit as well your data and select. And Legana said that Kevin is the regular expression master. So yeah, there are a lot of cheat sheets for regular expressions. And I guess that is literally, it's a language of how you do that. So these are the two things that I think it's maybe in the challenges is slightly new. I think that the challenge number 5 is quite cool because it even allows you to make plots using just plot. So it shows you how powerful the if-else statement can be in how much you can put in like how much you can do in just some lines of code. So yeah, I think I will finish there. If anybody has any questions or you are completely lost, I hope not. Let me know. Kevin put his information on the, wow, this is cool. Learn regular expression. There you go. Now we can all be like, go and try this. So I will share my, these are marked down in case you want it, because everything is already pasted there and I have some little notes. So it might be useful perhaps. So yeah, any questions? Are you completely lost? Give me feedback, otherwise it's not going to work. No, yes.
To answer Kath's question, recordings are posted